coordinates of a unit circle? What did we determine was true? If I counted over, because these are intense, we came up with something like that about-ish, right? What did we determine those were? What did those ordered pairs have anything to do with? Do you know what I'm talking about? Yeah. So the sine of 60 degrees is which of these ordered pairs? The 0.5 or the 0.87? Yeah. Do you remember this from last week or not? Okay, so just a quick review, because this will be on your test. Okay, this is theta. This is a right triangle within that circle. That's why we call it trig. This is x. This is y. This happens to be a unit circle. So the radius of this was 1. And so when we do SOHCAHTOA, what did we find out about theta, no matter what size of triangle we had? What was the sine of theta just using SOHCAHTOA? Yeah. And the cosine of theta was x. Did we do tangent of theta? Maybe we should do tangent of theta. What's the tangent of theta on this circle? What is the tangent of theta? Y over x. We can actually even write that another way. Who is y? If I had to do a replacement, who is y? It's the sine of x, yeah. And I should say sine of theta. Who's x? Cosine of theta. Have you seen that before? Not at all. So I'm just trying to get a kind of a feel for where you're at. All right, so this is a 60-degree angle. What would happen? I don't even want to use my protractor anymore. What would happen if you were to take your circle, fold on the y-axis? Would you be able to find this by just going straight over here? Could you do that? Could you visualize it? Go ahead and mark it. Let's draw that angle. And this is where trig is really essentially built, because a circle has symmetry in all lines. What would happen to this point? Would you know this ordered pair right now? What would it be? Negative 0.5. Good, because you went to the left. And what's your y value? Yeah. Would you know its angle? Would you know the angle measure from the x-axis? What would that be? Any idea? You know that this was 60. How did you get 120 degrees? You are right. What's that? Why did you add 30? Okay, so you measured off of this one? Is that what you did? Kind of. Is that, so you saw that to be a 30? Okay, what do you know about this axis here? Does it line up to this one over here? Obviously. So would you also would have known that this angle right here is how big? And it's the one we measured, so we kind of like to go off what we measured, but you're exactly right, Logan, that one is 30. So how am I getting 120 off of this? If you had to look at this, this was 60 up from the x-axis. This is 60 up from the x-axis, but what's the measure of this x-axis? 180 degrees minus 60 puts you in that spot. Have you done this before or You kind of remember this? This is where the paper plate, do you remember making that paper plate and folding, and you had like those little triangle things you cut out of those angle measures? Do you remember that? No? Why would that be handy to know? Why would it be handy to know 60 degrees? Would it help me know 120? Would it? Who else would it be helpful for me to know? Let's see, 60, 120. What else do I know because I know 60? How much? 150. How do I know 150? Where is 150? Which quadrant is it in? Quadrant 2. Let's graph 150. Do you have 150 plotted? Plot 150 with your protractor. Can you do that? So this in red, your circle is going to get kind of messy. That's 150 degrees. How does knowing 120 help me know 150? How does knowing 60 help me know 150? Does it help me? What would help me for 150? Knowing what angle? 30, wouldn't it? Because this reflects here. I know this smaller angle is 30 degrees. This smaller angle is 30. Therefore, I know 150. What were your coordinates for 30? 0.87 and what else? So then this over here is going to be, let's see, negative 0.87 and 0.5. So 150 is really good if I knew what angle measure. 30. So I think we got quadrant 1 and 2 pretty good with the 120, 150. What would a 60 in quadrant 3 really look like? How much? What is 60 in quadrant 3? Let's see. I can fold my circle around the y. Now I'm going to fold my circle around the x. So where would this blue line go? Would this blue line that represents 60 and 1, it would fold down here, right? How far down here would it fold? Remember, oh, say that louder. How did you get 240? If a 60 folded up, what's a 60 folded down? 180 plus 60, which is 240. So if I reflect that down, we can see where it's going to land. So go ahead and do that. So you shouldn't be even needing to measure with your protractor. You're just kind of eyeballing it, because I know that this is 60. Added on to that 180, it's now 240 degrees. And do I know its ordered pair? What do I know about its ordered pair? You can count if you don't believe it. What's your ordered pair? What's your x-coordinate? What's your x-coordinate? Negative 0.5. And what's your y-coordinate? Or 87, 86, but they're both negative, aren't they? So let's see, if I know 60, I know, what was it again? If I knew 60, I knew 120. So these are kind of pairing up. Let's do this. 120 came from knowing 60, as did 100 or 240. So what would it be in quadrant 1? Remember, you took your circle and you folded it down. What would it be in quadrant 1? Any idea what it would be in quadrant 1? What would this angle be? Remember, you have to go, oh, that's off, isn't it? It would be how much? How much would it be? You said it. What? 300. What do you think? 300 sound right? Okay. So this would be a 300 degree angle. And what would its coordinates be? Well, 0.5 and negative 0.87. So we call those reference angles. We call those reference angles. So we were able to see that a 60 in quadrant 1 produced 120 in 2, a 240 in 3, and a 300 in quadrant 4. Did you have to memorize those? Nobody ever made you memorize those? No? Did you know their relationship? You already knew all that? Yeah. So this is in degree mode, isn't it? So lots of times we don't work in degree mode. What do we work in? What's that other radian? So what is 60 in terms of radian? It's about 1 radian. Do you remember that? It's about 1 radian, but that's not accurate enough. Do you remember what it was in radians? Could you convert it? 60 times what? Over 180, right? And you reduce. And so what is the equivalent of 60 degrees in radians? Is that about 1-ish? Remember we kind of estimated that? So under your 60, go pi over 3. I have another note sheet I'll pass out here in just a minute. You should just be writing this on your circle. So we don't want to go and convert 120. We're lazy. There's got to be an easier way. So what is the equivalent of 180? 180 is equal to what in radians? How many radians were there? Pi, yep. So in terms of this fraction thirds, how many were in 180 or a half of the circle? In other words, how many thirds are in this angle 180? How many thirds? 3/3? Why 3/3? What does that produce? 180, right? So recall that, let's see, I was here and we had to back up. How much did I back up to get to this angle measure? I backed up 60. Well, what's the equivalent of 60? So if I'm at 3/3 and I back up a third, where am I at? 3/3 and I back up 1, where am I? 2 pi over 3. That's right. And how do I get in this one? Here I'm at 3/3, and how do I push down to get here? 1 more pi over 3, which makes how many? 4 pi over 3. Because remember, 3 pi over 3 was this line. I went another 60. So how the heck do I get here? Is this angle 60? No. This angle's 60. So how do I get this green angle that went all the way around? How do I get 300? I don't want to convert. I just want to be able to look at it in thirds. How many thirds is it? How much? You could see a pattern, couldn't you? How many is it going to be? 1 pi over 3, 2 pi over 3. I think it's 5 pi over 3. Go ahead. Oh, this is 6 pi over 3, isn't it? And then what'd you say, Molly? That's 6 pi over 3. And then how do I get back down here? I took off a 60-degree angle, which is how much? 5 pi over 3. Does any of that make sense to you? So when you said you memorized, when we first started this, what did you memorize? Your plate. What did you memorize on your plate? But did you have to memorize them? Did you need to memorize these? Okay. Okay, so we have to get rid of this memorization thing. So let's just watch for just a second here. And maybe now that you've had to memorize it, maybe it started to make sense to you. So if I'm at a 30-degree angle, okay, because of symmetry, would you agree with this? All of these are 30. Would you agree with that? So a 30 on my unit circle has the same XY coordinates as which angle? What is the angle measure of this? Remember how you measure an angle? All the way this direction. Well, if I know this little sliver is a reflection of this angle, how big is the green angle that I want to measure? How did you get 150? What did you do? Yeah, I always go to this axis, 180, back up 30. How do I get to this one? Add 30. And how do I get to this one? Go all the way around and then back up, and what do I get? 330. Now, why is it useful to know those? They're called reference angles. So if I know everything in one, I know the rest of the circle. Would you agree? So let's try that in radians. Do you know what 30 degrees is in radians? Okay, let's verify that. Everybody agree with Shadell? It's pi over 6. So if this is pi over 6, I know that you went to 180 backed up. Well, who is 180? Who's the equivalent to 180? 6 pi over 6, exactly. So you have to back up one, so where are you? And think of the fraction 5/6. Is it a full pi? So where are you at here? 7 pi over 6. And then where are you at here? This is the hardest one. So Molly said go all the way around. So where are you at in terms of sixths? 12 pi over 6. And so you are right, 11 pi over 6 once you back that up. So if you know one, there's no memorization needed for the rest. Yeah? Okay, so there's only certain angles that we have to do this with. Do you know your certain angles that you have to use? If I go the sine of 50 degrees, because you measured, did you get about 0.8, 0.75, someplace in there, did you? Yeah or no? Yeah? Okay, so can you tell me then, let's envision the unit circle. Can you tell me then the other relations to 50? 50 and 1, quadrant 1, is the same as what angle measure here? Come on, go all the way around, back up, where are you at? 130. Okay, so let's just, you don't need to measure on your thing, let's just check here. The cosine of 130, we're hoping is what? 0.64? Oh, it's negative. Why is it negative? Because you're in quadrant 2 and it's the x-coordinate. So if I go the sine of 130, I'm going to get the same thing. So what would that 30 be? Oh, sorry, the 50 be. Remember, we're doing 50. I need to remember that. We're doing 50. Now it's 130. What would it be in this quadrant? What would it be? So go all the way around, either back up or go forward. So what's it going to be here? This is how much? 180 to here. Go another how much? 50, right? And what's it going to be? 180 and 50 is how much? 230. And we can quickly check. Sine of 230. Why is it going to turn out to be negative? Because you went down. What would it be in quadrant 4? Let's see, go all the way around. Back up, what would you get? 310. Okay, sine 310. Why is it also going to be negative? Yeah, that to me is like so simple. Do you think it's simple? It's like, what the heck? But so useful. It's incredibly useful. So I don't know that degrees give you a problem, do they? Do degrees give you an issue or not? Huh? No? Okay, so let's look at your notes here and let's start to fill in just a little bit on here, like what was going on our circle. So a unit circle, couple things, has a radius of 1. This works for a radius of 1. Reference angles. First of all, what quadrant are they located in? All your reference angles are located in what quadrant? Quadrant 1. They're all those angles from 0 to 90. Where do they come from? What axes do you always measure off of? The x-axis, right. You have to, and that's where we started. It's always off of x. Forget y. And why are they useful? Why is it nice to know all of one? Because what does that tell me? I know all the rest. Yeah, I know all the rest. In other words, I know quadrant 2, 3, and 4 because of that idea of reflection. So let's list them here, and you'll use these so much pretty soon you'll get used to it. So here's how I think about it. I go to 180, I back up. I go to 180, I go forward. I go to 360, and I'm backing up. So I'm in quadrant 4, and that would give me 330. Does that make sense, the forward back up business? Here's in my mind what I'm doing. I have this little sketch. And after a while, you'll plot this sketch almost every time because it's very helpful. If I go all the way to 180 and I back up, I'm at 150. If I go all the way to 80 and that 30 more, I'm at 210. If I go all the way around to 360 and back up the 30 I need, I'm at 330. Do you get my forward back up business? Works every time. So let's go down to 60 because it's one we've already done. So what is 60 in quadrant 2? Go all, back up. What is it? 120. Everybody understand where Molly got 120? And you don't want to convert all this. It takes way too much time. Go all the way and go forward more. So where are you at? That's right. Go all the way around, back up. So you're in quadrant 4, and who do you get? All right. So 45 is a little bit different, but again, it's going to be an angle measure that we're going to use a lot. And we use these because they are special right triangles. They appear all over the place. Okay, 45. So here's 45 in 1. What's 45 in 2? Let's see, go all the way. Subtract off 45, and what do you get? Okay. Go all the way to 180 and add on 45. What do you get? 225. Okay with that? And then the last one's what? Go all the way, subtract off 45. What do you get? 315. Now these are nice because if I know 45, I know them all. Okay, I know all those other angles. So pi over 6. Okay, let's write this down so you kind of have a reference. Pi over 6, again, I see this circle, but now I see it in 2 pi's and pi's. I see a fraction. So in order to deal with fractions, we need common denominators. This is 6 pi over 6. This is 12 pi over 6. So quadrant 2 would be how much? How much? Go all the way, which is how much? 6 pi over 6. Back up 1, where you're at. Where? 5 pi over 6. Do you see how we got that or not? Donovan, you see where we're getting that okay? All right, so what about in quadrant 3? Go all the way. And then an additional one, what do you get? What's the additional one? What do you get? 7 pi over 6. And in the very last quadrant, you had to circle all the way around, take one off, and you are at 11 pi over 6. Okay, let's try pi over 3. So now this fraction is 3 pi over 3, or 6 pi over 3. So you just change your denominator. Go all the way, take off 1, 2 pi over 3. Go all the way, and an additional 1, 4 pi over 3. Go all the way around, take off 1, 5 pi over 3. So don't try to memorize these numbers. Okay, that's exactly how I do it every single time. Pi over 4. Well, that's fourths, right? And so this would be 8 pi over 4. So what would I get for quadrant 2? Rattle it off. What would I get? Okay. What would I get in quadrant 3 then? Okay. And in the last quadrant? Makes sense where those numbers are coming from? Okay, so what if I give you these and say, I want to know the angle in quadrant 1 in which these are equivalent to? How would I do that? This is a little bit harder. What would I do? Who am I always measuring off of? The x-axis, exactly. So I have to ask myself, how far away is 150 from the x-axis? How far away is it? 30 degrees. 230. Well, I kind of like to draw it a little bit, just a sketch. I don't like to measure. What is the angle I would need in quadrant 1 to find this value? How far off of the x-axis is it? 50, isn't it? Questions on where we got that? 310. How far off the x is it? Another what? Is that helping how to look at that circle? It always seems when we give you fractions, it becomes a struggle. Okay, you're always looking for a full pi. How far away from a full pi is it? Just look, it's 3/4 of one. How much more do you need? You need one more, don't you? 2 pi over 3. It's not quite a full pi. How far away are you? And the last one. I'm beyond a full pi. I'm closest to whom? Who am I closest to? 2 full pi, so how far away am I? Pi over 6. So we're just going to stay with reference angles today. So here you go. You ready? 5 pi over 7. What quadrant does that land in? 5/7 of a pi. What quadrant does it land in? Quadrant 2. Who's its reference angle that I would use in quadrant 1? 2 pi over 7. Okay, let's try another one. I think would you agree the fractions are more difficult than the angle measures? That's where I always had trouble too. Okay, let's go 9 pi over 8. What quadrant am I in? Think of 9/8. Quadrant 3. Well, how'd you know it was quadrant 3? Because you're just a smidge more than 1. You're pretty far away from 2. Would you agree? Okay, so what's its reference angle? How much away from a full pi am I? What is pi over 8? Who cares? It doesn't matter. It's in quadrant 1. Okay, so what if I gave you 21/11 of a pi? Where are you at? Are you more than, is this bigger than 1? It's almost how much? Do you agree it's almost 2? So what quadrant are you in? You're in quadrant 4. So what's your reference angle? How far away are you from a full 2 pi? That's all you're asking yourself. Pi over 11. Helping-ish? Kind of. Okay. 17. Let's do this. 16 pi over 9. What quadrant are you in? What would you guess? 3 or 4? Why would you think 4? It's almost 2 pi. So it is in quadrant 4. So what is its reference angle? It's an ugly fraction. I'd never ask you to do this, but if you can do this, you can do them all. What is it? 2 pi over 9. 10 pi over 9. Where are you at? You are in quadrant 3. What's your reference angle that you would use that would help you find this? Pi over 9, because you are 1 beyond a full. So do reference angles somewhat make sense to you? Do you understand why we use them and find them? So tomorrow, let's see, let's look at your homework assignment.